Hello everyone and welcome back to my channel. In today's video, we're going to be looking at this very interesting part of maths called logarithms. So let's get into this video. To start with, let's look at this question, which says, how many digits are in the number 20 raised to the power of 12? What this number really is 20 is written like this, by the way. And this means that 20 is raised to the exponent of 12. So if I were to explain what exponents are, that would be if we have a number like 2 raised to the power of 2, this means that I multiply 2 by itself 2 times. Alright, so 2 would show up in the expansion of this basically 2 times. If I had 2 to the power of 3, it would be 2 times 2 times 2, so this happens 3 times. Alright, but if we had a number like n to the power of x to the power of x, then this would mean that I multiply n by itself x times. Alright? So that's basically what exponents are. Something else that we might want to note is that this number over here, which is 20, this is called the base. Okay, so that's basically what exponents are. Now you might go on and try to work it out, like 20 raised to the power of 2 is 400, then we move on to 20 raised to the power of 3, which is 8,000, and then 20 raised to the power of 4 is blah 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 blah, and you keep going on like that, but it may be very tedious work to go on and on like that. What if I told you that there's a way to do this in just a minute? Yes, you heard me right. 1 minute is all you need to answer this question. Really, really easy. So, let me introduce to you the hero of this video, logarithm. It's a function in maths which is called logarithm. This is an absolute sweetheart for us. Sweetheart for this question, because what it does is to completely simplify this question. Obviously, we have to start by understanding how we can use logarithms for this, but this is a complete sweetheart. So, without further ado, let's learn about this sweetheart. So basically, since I said that n raised to the power of x is equal to n times n times n x times, what this would mean is that when we use the function of logarithm, so when we use logarithm over here, this would mean that we're going to be reversing exponents, and we're going to be asking what exponent should I raise n to to get the answer of n to the x. Obviously, this is going to be a number and we're not going to write it like that. Otherwise, it's going to be too easy and we're just going to say x. But how this logarithm function does this for us? Let's take an example. Let's say we've got 10 to the power of 2 is equal to 10 times 10, right? Which is equal to 100. So, when we ask what exponent should I raise 10 to get the answer of 100, we will get the answer of 2. So the way you write this is you write log, shortened form of logarithm. You write a little 10 if we're working with the question 10 squared is equal to 100. If we're working with that one, then you write a little 10 to show that the base, this is the base, right? The base we're working with is 10, and in brackets you write the number. So now this is going to equate to 2. That is a sweetheart. But anyways, how can we use this for our question? Obviously, we can't go straight up and start trying to use this because it might get really difficult and we'd surely need a calculator for that. So, I have memorized the value of log base 10 2, which is really useful. And let me tell you why. Let's start with the first identity that we need for logs. So if we've got something like log base 10, or actually any base with something like x to the power of z, then this is equal to z, not capital Z, obviously lowercase z, log n times x. So log base n x. Alright, so that is our first identity. What this basically is that if we've got log base 10 20 to the power of 12, we can write this as 12 log base 10 20. Now let's look at our second identity, which is log base n mx, let's say, is equal to log base n m plus log base n x. Alright, so what this means is that we can write this as 12 log base 10 2 times 10. Is that true? Yes, because 2 times 10 is 20. And now we can expand this into 12 log base 10 2 plus 12 log base 10 10. Okay, so now I know the value of log base 10 2, which is 0.3 approximately. There are a lot more numbers after 3, but this is the approximate value, and we can multiply this by 12 because that's what it's equal to, plus 12. And since we're asking what power, what exponent should I raise 10 by to get the answer of 10, that would be 1, because 10 to the power of 1 is equal to 10, right? So we don't need to worry too much about that. So we can just go ahead and write times 1. Now this is equal to 3.6 plus 12, okay? And that is equal to 15.6. But now something to note. This is not the end of our answer. Let me explain why we were using base 10 and logarithm to find this. Because basically, when you have a number like log base 10 100, right? We get 2. Log base 10,000, we get 3. And as we keep increasing, the digits in this here increases by 1, right? So because exponents of 10 basically go like this, and you just keep adding on digits. So this basically counts the number of digits in here, right? So we need to add 1 to this number. We need to add 1 to this number. Why? Because does 100 have 2 digits? No, it has 3. Does 1000 have 3 digits? No, it has 4. It has 3 zeros, but it has 4 digits. So that's why we need to add a 1 to get 16.6. Now here comes the slightly confusing part, which I've noticed, is that we round this number down. So we round this number down to 16. And this is the case every single time with logarithm. So if you've got something like log base 10 999, and that gives you a number like 3 point blah 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 blah, not 3 point blah, it would be 2 point blah 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 blah, and then you add on a 1 and then you get 3 point blah 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 blah. You always round it down to 3. Alright, no matter how big this number is, maybe there's a 9 after it, you round it down to 3. So that's why we're going to round this down to 16. And that, my friends, is the answer to this question. There are 16 digits in this number, in 20 raised to the power of 12. So I hope this all made sense to you. If not, please comment down below if you have any questions. Other than that, that's all for this video. Thank you so much for watching. Have a great day. Bye!